All right, so now again, we are going to deal with triangles, but this time we're going to do it using trigonometry. And all trigonometry is the study of the relationship between angles and the sides of a triangle. That's what trigonometry is. Now, what we are going to start off with is a certain type of triangle, a right triangle. And a right triangle means we got ourselves a 90-degree angle in there. Now, with trigonometry, a triangle has three sides. They each have a name. Now, the side that is always across from the right angle, that is called your hypotenuse. All right, now it's key, and you've probably dealt with the hypotenuse before when you're dealing with Pythagorean theorem, but the key for the hypotenuse is it's the longest side. Now, again, most often in trigonometry, that's useless information because you don't know all the sides of the triangle. And so the way to find the hypotenuse, again, it's always across from the right angle. Now, in trigonometry, you have the hypotenuse, which is across from the hypotenuse, or the right angle is across from the hypotenuse. But then there's two other angles. And in trigonometry, we have to pick one of those angles or we'll be given one of those angles. So I picked angle here in red, and you see that little funny symbol there? That's a Greek symbol called theta, which just is just used as notation to say that that is just some angle. Now, when you have the side across from that particular angle, and so in this case, my red angle, that is called the opposite side. All right, so again, that is the side that is across from the angle that we know or the angle that we're trying to find out. We will do both. And then finally, there is a third side. That is the side that is adjacent to that angle. Now, for me, when I was in high school, I wasn't very good with English. And so I didn't know, trigonometry confused me because I didn't know what adjacent even meant. And what adjacent means is beside. So this is the side beside the angle we're looking at. That's all. So we have three sides that we're concerned about. The one across from the right angle, which is always our hypotenuse. Then we're given or trying to find another angle. The side across from it is your opposite. Your adjacent is the side beside it. It's the beside side. All right, now the next step is that for trigonometry, there are three basic trig ratios that you need to know. And again, a ratio, just looked at that with similar triangles, can be written as a fraction. That's how we're going to write it. Now, the three trig ratios that you need to know are called sine, cosine, and tan. Now, I'm going to leave a little bit of room here because there's a way to remember these ratios, because this sine ratio, and I write it as sine theta. So this is the sine ratio looking from that angle theta, is you take the opposite and you divide it by the hypotenuse. That's the ratio or the fraction that the sine ratio represents. Take the opposite side and divide it by the hypotenuse. The cosine ratio, or cos theta, is that we take the adjacent side and we divide it by the hypotenuse. And that would be our cos ratio. And then our third ratio, the tan ratio, which I call tan theta. So we look, or you take the opposite side and you divide it by the adjacent. Now, you have to know these three ratios, all right? Here's how I remember them really quickly, is I have three different phrases that allow me to remember these three ratios. The first one is a sine ratio, in which I use the phrase sine on highway, where I look at the letters, the first letter of each of those words. The sine ratio is the opposite divided by the hypotenuse. The second ratio that I use for cosine, or the second phrase, I guess I should say, for cosine, is I use cozy at home, which hopefully many of us are at right now. Again, looking at the first letter of each word, the cosine ratio is the adjacent divided by the hypotenuse. Cozy at home. Sine on highway, cozy at home. And the third one, which I would love to have right now, is a tan on arms. Again, looking at the first letters of that phrase, the tan ratio is the opposite divided by the adjacent. So those are 3 trig ratios that you need to know to be able to do trigonometry in the next couple days. All right, now, how do we use those or find those? Well, let's get to an example here. All right, so here we go. Given the following triangle. So here's our triangle. We have, I'm going to draw a little bit bigger. There we go. And again, because we are looking at the first type of triangle, which is a right triangle. All right, I have sides A, B, C. I have a 13 here, a 12, and a 5. All right, and here's what I want to find. Find A, sine A, B, cos A, C, tan A. And I'm going to keep her going here. D, sine C, E, cos C, and F, tan C. All right, so I'm going to explain what each of those mean and how we're going to find them. Now, let's start off with the sine of A first. What the sine of A means is I'm looking for the sine ratio, sine on highway, opposite divided by the adjacent, or sorry, opposite divided by the hypotenuse. So opposite divided by the hypotenuse. Now here's the thing. The A is telling us which angle we're looking from. So here we go. We're looking from angle A. Now, I'm looking for the opposite. And again, the opposite is the side that is across from the angle you're looking from. In this case, this A is telling us what angle we're looking from. All right, now the side across from that angle is 5. There we go. Whoa, got an emergency there. Now, the hypotenuse is always the side across from your right angle. So that's a 13. And so if I'm looking for the sine of angle A, I have the fraction 5 over 13. Or as a decimal, 5 divided by 13, I get 0.38. All right, next up, I'm looking at cos angle A. So again, I'm looking from angle A, but I want the cos ratio. Again, that's where I use my phrase, cozy at home. At home, the adjacent divided by the hypotenuse. Now here's the thing is, I already found the hypotenuse, no problem. It's always again across from the right angle. So again, it's 13. So there's my hypotenuse. Now my adjacent, that is the side that is beside that angle that we're looking from. Again, we're looking from angle A. Now check this out. There's 2 sides beside angle A. There's a 13 and a 12. But the 13 is the hypotenuse. That means 12s are adjacent. So again, because two sides are actually beside angle A, but 13, because it's across from the right angle, that's our hypotenuse. That makes 12 our adjacent. And so if I'm finding the cosine of angle A, let's see, I take 12 divided by 13, and I get 0.92. All right, last one for this, tan angle A. Again, looking from angle A. Tan on arms. On, opposite. Arms represents the adjacent. All right, so again, looking from angle A, I go across for the opposite. It's a 5. And my adjacent, again, we talked about this, the side beside the angle, it's a 12. And so I take 5 divided by 12, and that will give me my tan of angle A. 5 divided by 12, we get 0.42. All right. Now, next up, sine of angle C. So now we're finding the sine ratio again, but we're looking from a different angle. There's only 2 angles you can look from. In this case, it's either A or C. You can never look from the right angle. All right, you can never look from the right angle in trigonometry. So this time we're looking from angle C. There it is. And again, sine on highway, that is the opposite divided by the hypotenuse. All right, so again, the opposite is the side across from the angle we're looking at. So that is a 12. The hypotenuse, it's not changing. The hypotenuse doesn't change. It's always going to be across from the right angle. So again, it's a 13. And if I take 12 and I divide it by 13, I get 0.92. All right, cos C. So again, cosi at home, adjacent, at home, hypotenuse. Okay, again, we've talked about this. Hypotenuse is 13, so I'll put that in the bottom. All right, what side is beside the angle C? Well, 13 and 5, but we already know again, 13 is a hypotenuse, so the side beside it is 5. And if I take 5 divided by 13, I get 0.38. And now our last one, the tan of angle C, tan on arms. On is opposite. Arms is adjacent. And so I look at what I got here. The opposite of angle C, again, across from angle C, that's a 12. The adjacent, the side beside angle C, it's a 5. And so when I go to 12 divided by 5, whoops, 12 divided by 5, I get 2.4. Now, here's the key. When you look at our values, we have the same triangle, but you look at the values of sine are different, cos are different, and tan are different. The decimals are different. We are looking from a different angle. Because we're looking from a different angle, you get a different ratio because the opposites and the adjacents change. And again, that's the big thing with trigonometry, what angle you're looking from. All right, so that is the start of trigonometry. You have to know your trig ratios and be able to write down your trig ratios to do what we're going to do here at 11 o'clock, which we're now going to use trigonometry to solve for some information. All right, so I'll see you at 11 o'clock.